Hi, Mick McQuaid here with a little patch video. There was a problem with the lab, the day 6 lab video, iste780day06-lab.mp4. That video has a screen freeze starting at 43 minutes and 9 seconds. And from then on, you can only get the audio, you cannot get the video. So I'm making this little patch video so you'll have something on the screen for the rest of the time. So stop watching that video at 43:09 and start watching this one. The very last thing that I do on that one at 43:09 is this plot here on line 47. And that plot just showed us that there was not a pattern to the residuals. And I've cleared the screen here. And now I'm going to go on to a fifth degree polynomial fit of LSTAT, that's low socioeconomic status, as a predictor, or I guess you could say as 5 predictors of median value. So I'll create that, oops. And look at a summary of it, and we see that all 5 are significant. So this is a list of the 5 variables plus the intercept plus beta naught. And the 3 asterisks next to each one suggests that these p-values are very small indeed, small enough that they're hard to measure. They're in the vicinity of 0 as far as this computer is concerned. This computer can't measure below this number right here, I think. So all 5 of these are significant. The authors claim that they did this on higher degree polynomials and that none of those were significant. So this was as far as it goes. And I'm not sure that this is that valuable. If the difference between this and the second degree polynomial, which gives us, I think, 63% or 64%, I don't think it really warrants all these additional variables. But there could be a case where this is a make or break difference for you. So that being said, let's just move on. So one thing that the authors want us to understand is that we don't just have to take polynomials. We can take other functions. So here's a sublinear function of Rm, and we're just going to look at the summary of what that would produce, and that explains only 43% of the variability. These are by themselves, these are significant, and you might, I think RM stands for number of rooms, and it might be the case that the increasing value of rooms is a sublinear increase. In other words, the difference between 3 and 4 rooms is greater than the difference between 4 and 5 rooms. That may be the case. That's certainly the intuition behind modeling it this way. But I would not stop there. I would certainly look at what the raw variable itself produces. So that's what I've done on the next line here. And we get a slightly better R squared with the raw than we did with the log. And you really want to talk to a realtor to figure out how best to model these things. You want to try to figure out whether or not rooms, the value, increasing value increases linearly with the number of rooms. My guess would be that it doesn't. My guess would be that the log is the better predictor in a more sophisticated model that takes a lot more into account, and particularly takes location into account. Location, according to realtors, is what counts. And we saw earlier that LSTAT, the percentage of low socioeconomic status in the neighborhood, was significant, much more significant predictor. Okay, now you can, just as we attached the Boston data set, we can detach it. So I'm going to detach the Boston data set here, if I can ever do it right. Okay, there, I think I just did it, yeah. And I'm going to attach the car seats data set. And the car seats data set is about the sales of children's car seats. These are the child safety seats that go into the back seats of cars, and or usually go into the back seats of cars. And I think they're actually illegal in many cases. I think they're illegal in front seats unless you don't have a back seat in the car or something like that. So here are a bunch of variables that might explain sales. So sales is the dependent variable here, and there are various pieces of information, such as the amount spent on advertising. Shelf loc is a very useful one. Shelf loc for us is going to be our qualitative predictor. So here we're going to be looking at qualitative predictors. So that's important. And then some of these others are perhaps qualitative predictors as well, but I can't remember right now. Okay, and so what we're going to do here is a new model, and we're going to take everything. So we're going to take all of these things as predictors of sales, plus we're going to take the interaction of income and advertising and the interaction of price and age. And if you recall earlier in the lab, we used an asterisk. And when we used an asterisk between them, what it did was included income and advertising individually, as well as the interaction term. And this only includes the interaction term. Including the term itself would be a duplicate, since we've already included it using this dot right here. And so what we get from this is a list of these variables, and we see that quite a few of them look significant. Income advertising looks significant. And what's price age? I don't see price age. Oh, here's price age, turns out not to be. Okay, price age is not significant in this model. So the interesting thing here, though, is shelf loc. So shelf loc has three values: bad, medium, and good. So you can your car seats can be well located in the store, or they can be mediumly located or poorly located in the store. And the way that these are, here, let me just do contrast, because I think it's going to be clearer if I do it that way. What do you mean shelf loc not found? Didn't I attach car seats? There it is. Okay. Huh, weird. Okay, so the variable shelf loc good is an indicator variable. It takes on a value of 1 if the shelf location is good, and it takes on a value of 0 otherwise. If shelf location is medium, then shelf loc medium takes on a value of 1, and it takes on a value of 0 otherwise. But suppose that both of these are 0. We don't need an indicator for the third variable. If these are both 0, then the contribution is going to be recorded as the intercept. And so this is why in indicator variables we need one less variable than we have conditions to cover, because we can use the intercept to cover the unnamed one. So if we set all the other ones, however many we do, we can set them all to 0, and then the intercept will cover for the remaining one. I hope that's clear. And so that's just an example of how R automatically handles qualitative variables. And that's really the only point in bringing that up. Then the very last thing that we'll do here is writing a function. And this is an extremely simple function called load library. So first let's check to see if such a function exists. And when we check, we get an error message that says object load libraries is not found. So now I'm going to qualify that and put parentheses after it so that R will know that I'm looking for a function. So now I get error could not find function load library. So R knew that I was looking for a function because it had parentheses at the end of it. But there is no such function, so that's that. So let's create that function now. And all this function is going to do is to load these two libraries, which currently are already loaded. So it's not much use to us right now. And then print out the message that the libraries have been loaded. Now this is potentially useful in an initialization file, and I have an initialization file. And I have things, for example, notice that all this stuff is in color. If you're using terminal R, you may not have everything in color. Well, the only reason that mine is in color is because in my initialization file, I specified that I wanted the output to be in color, which it's not by default. And it's a little bit of a pain to do that, to the color thing. It's hard to remember, so it's better that I just have it in the initialization file. Okay, let's see now. Okay, so we're going to write this function, basically all we have to do is give it a name, say we're creating a function, put the function in curly braces, and then write it. And we can just write it one line at a time like this. So I'm just going to type in one line at a time by passing my text editor stuff over to my R window. And you can see that R knew that I wasn't finished typing because of all these plus signs until it saw it recognized the curly braces as the beginning of a construct that would have to end before it would be willing to say that this is ended. Okay, so now let's go back and say load libraries and see what happens. Now, if I just say load libraries by itself, it actually shows me the definition of the function. What if I just say load libraries as a function? It actually exercises the function. Okay, so and if I put if there were parameters, I could also put parameters in there and possibly alter how the function is loaded. So functions are valuable. We're going to create a few functions in this class, not too many. They're fairly simple ones, but it's worthwhile. It can speed up your work a lot. And it can help you to understand other functions. So you might, in machine learning kind of stuff and big data type of stuff particularly, people are coming out with new R libraries every day. And it can be difficult to understand them. And so it can be easier to understand them if you know a little bit about how they're written rather than just having to do trial and error guesswork with them. Okay, so that's the end of this lab. That's the last thing in the lab. And now you have homework to do. So good luck with that. Thank you for your attention. And I'll look forward to talking to you tomorrow.